So now this is the Suffrage algorithm for task scheduling. This one is, in my opinion, the most tricky one for me. So because we need another extra data structure to store the information we encounter during the iterations. The idea of Suffrage is that, so for example, if we are iterating this row here, and we will get the first minimum value, I mean the smallest one, and then we get the second smallest value from this row. Sorry, does not include the last column. We get the first and second smallest value from the row here, and then we get the difference between them, and then we call that suffrage. So in this case, we need another data structure here to store this information, and we can get that from this. So this is a list, and in the list, each entry is array, is a double array. I just use double because it's easier for me to handle the data. The double array here. The first element in the array is cloudlet ID, and then second one in the array is suffrage. So it will show, say, for cloudlet 1, what's the suffrage, and cloudlet, and see we have 3 elements in the list. The first one, the index will be 0, which will correspond to virtual machine 0. Second one will be the index will be 1, so it will correspond to virtual machine 1. Third one will be, of course, virtual machine 2. And all the first element is also cloud ID and the suffrage value. So if we go back to the code here, this is the main method for this algorithm. Again, we have a double array to record the ready time. This is what I just mentioned, the list to record if the virtual machine has been assigned. In the list is double arrays. And then in the beginning, like I said, the first is the index of cloudlet, and I use double for simplicity reason. Second one is the corresponding suffrage, and then we initialize that as 0.0 and 0.0. And then we add this array, double array, into this VM suffrage list. Then we continue to initialize the two-dimensional matrix as we did before, and we enter this do while loop step. The first step will mark all the machines as unassigned, which means all these values will be 0.0, all of them. And then in this is the nested loop here. Nested loop. In this nested loop, what we need to get are 2 things. First, we will get in each row, we will get the minimum value and its related row, column, index, cloudlet informations. This is one thing we need to get. Another thing we will need to get is the suffrage value. As we see here, we use this integer array to record this all the information, related to this row, and we use this double array to record the all the rows without the last column. If we look at the picture here, this one, so we use that double array to record basically here, everything here. Do not count the last column. And we will use all the values here in the row to calculate the suffrage in later calculations. So here we keep going the inner loop to get the smallest in each row. So see here, note that I didn't use a map to store the information here because I just want to try something new. Map is kind of like a little bit more complicated, and so I just use the integer array to store all the information. Besides, during my implementation, I found it's actually quite hard to use map in this situation. It's a lot easier just use this integer array and a double array. So this double array, like I mentioned earlier, we gathered all the row information here, and we pass this row to this function, and we can get the suffrage for that row. And this function will be talked about later. And then we check the suffrage to check this suffrage list, and we will check if for each virtual machine we will check if it's being assigned, and also if it's being assigned, what's the current suffrage value. If the incoming suffrage value is greater than the current one, we will replace the old one. And notice that this is done in the inner loop, because we need to check if the virtual machine has been assigned the stuff, and after every time we finish iterating a row, so this replacement does not. After that, we just my point here is this check suffrage is inside the inner loop, because we need to scan each row. And see, this is the end of the inner loop. After that, we need to check. We need to assign the cloudlet. That means we have scanned after the loop. That means we have scanned every row. Then we need to do something to assign, based on the current information in the suffrage list. We need to assign the cloudlet to the virtual machine and then update everything. This is another helper function. So this is the main body from here to here. This is the main body for the suffrage algorithm. Now we will look at how to calculate the reset and calculate the suffrage. Of course, we need to reset every time in the beginning of the do while loop. It's very simple. Just set everything to 0. And I use the print out line here to keep track of our progress. And then calculate suffrage. It's very efficient. It does not require nested for loops. I refer to this reference here. It's kind of like a dynamic programming technique. You evaluate the value and move backwards one by one. Assign first one to second, and then assign the current one to first one if some conditions is met here. If the current one is less than the first one, and also there's some other check. At least we have 2 elements here, and then print the line to keep track where we are, and then get the suffrage. And that's it. Just return this double value. Then we will look at the check suffrage function. It's we check the virtual machine has been assigned. This is the code. So basically what it does, I will use this picture to explain. Like I mentioned earlier, in each array, the first element is the cloudlet number to assign to this virtual machine. So for example, 0 at the index 0 position. Second one is the related suffrage value for this cloudlet. So then we check if the suffrage value is not 0.0. Remember, just in the beginning of them, all of them are zeros. So if it's not, so the suffrage value if it's not 0, it means there is a cloudlet assigned to it. Then we assign this cloudlet to the current virtual machine after, and then update the ready time, remove the row, update the total time matrix. So if we go back to the code here, got the existing cloudlet ID, existing suffrage from this list, VM suffrage list, and then we check if it's not 0.0. If it's not, then that means there's an existing cloudlet and suffrage there. If it's not, that means there's no cloudlet there. We just assign directly to it. So this is another case. If when the cloudlet has not assigned there's a cloudlet assigned to the virtual machine, but I'm sorry, it's not. So this case when there's no cloudlet assigned to the virtual machine, or the cloudlet has been assigned to the virtual machine, but the value, suffrage value is less than the incoming one, so it will need to be replaced. This is check condition: is existing suffrage less than current suffrage, and then we just create a double array, and we just set. Remember, this is a list. We can only use set method to change the value. It took me a while to. I was quite a little bit lost when I was doing this, but I finally figured this out. After the check suffrage function, we will go to the last important helper function here. Is to remove a row from matrix based on cloudlet ID. Previously in max-min and max-min algorithms, we just remove the row. I said we cannot rely on remove the row based on the row index. But in fact, because we used map data structure in min and max-min algorithms, so the row index and the column index information, they are retained actually. I was wrong in the previous videos. They are retained very well. So we can simply use that. I'll show you real quick here. The min algorithm. See here, if we go to the remove, the matrix remove will just pass this row index as the parameter. If we go up, the row index is actually here. We get this row index from this integer array. Where we get that integer array, we get that from the map. Because this is what I mentioned, because we use the map. So every information, the order, they are retained. So it does not change the order. Again, I was wrong in the previous video explanation. Despite that, adding the column, the fourth column, is still helpful for me, understanding the updating progress and everything in between. Now we go back to the suffrage algorithm here, but in this algorithm I didn't use map, so I have to all the information I have is the cloudlet ID. So I have to come up with another method to remove a row from the matrix based on this cloudlet ID. It's actually pretty simple. Just iterate the matrix, iterate this matrix, and found. See this target. We got the row and the column -1, and we got the last column. We actually got this one, and then we just check if it's matched to the passed in cloudlet ID. If it is, and then we just remove that row based on this current row information. And of course, there's another simple helper method to print out the list of double array, which is a suffrage list in this case. It's just help me to understand the intermediate results. And if we run it, this is the results. So the first iteration, we got the matrix here, and we keep track of everything. Suffrage reset successfully. Everything initially as 0.0, and then we get for the first row, the smallest, second smallest suffrage, and then we temporarily assign this cloudlet 0. We'll try virtual machine 1 because the suffrage, the minimum value is 13, so it will try to find virtual machine 1, and we just temporarily assign that to the position 1, index 1 position in the suffrage list, and then we update this temporary suffrage list. As we can see here, suffrage list with the current suffrage is 15, and we keep doing this for the second row, and the suffrage is 35. The minimum value is 17. Also goes to virtual machine 1. 35 is greater than 15, so it will replace 15 and update the cloudlet 1, update the information, so it will say cloudlet 1 with suffrage 35. And keep doing that. There is if I remember correctly, there is one situation that in the beginning, it's always like all the cloudlet will go to virtual machine 1 in this particular case, but there's one condition that there are two cloudlets to different virtual machines in the same time, in the same iteration. This is the case I just talked about. So you see iteration 5, it starts with 5 by 4 matrix, but if we look at the next iteration, iteration 6, it's 3 by 4. That means there are 2 rows removed in that iteration. If we see if I can find it, so here, so cloudlet 0 with cloudlet 3. So these two, they are assigned to different virtual machines in the same time. And that's it for the suffrage algorithm.